Okay, so this gets 1, 2, 3, 4 all the way to 25, right? We start at 1 because this is 1. We start short of 25, short of 26 because this is 26. We never get there. And then we reshape it. There's only one way to have 5 rows if the item goes from 1 to 25. It's by having 5 columns, and then you print it, and that's what you get. 1 through 5, 6 through 10, all the way to 25. And here we are grabbing slices. Grab the first row. So we're in this row. Which columns do you want? From 3, and you stop short of 4. So it's just 3. 0. This is 0. This is 1. This is 2. And this is 3. So this is the item at row 0 and at 3 at column 3. So this is 4. So when you run this, it gets you 4. How about the second one? Give me all of the rows, and then the column 1, 2, and 3, right? It doesn't get to 4. So this is column 0. This is column 1, 2, 3. So that's what you get. 2, 3, 4, 7, 8, 9, 12, 13, 14, all the way through 22, 23, 24. And that's what you have obtained here. Can grab the type with the type function in Python. It tells you it's an ND array, meaning n-dimensional array, which means multi-dimensional array. And now we move on to control structures, and the focus is on for loops. So we can specify initial flow rate, we can specify Q, or basically initialize Q to a vector of the size of tvec. So we created tvec previously, and whatever the size is, Q will be the same size, right? Because Q is evaluated at T. So if there are 100 items in T, there will be 100 flow rates, right? So now we can go from each T in tvec. So this T will become the first item in tvec the first time through. And because we don't have tvec here, how about we create it right here? So we can say tvec, it was created earlier. Well, I want us to do it afresh. So tvec equals what? We're going to use NumPy array range. And let it go from 1 to, what do you want? Let's make it short this time. Let's go to 10. So we make it 11. So it starts at 0, stops at 10. And then this is what your tvec is. So it's 0, 1, 2, 3, all the way to 10. So the first time through, T will be 0, which is the first item in tvec. So you can print T, it will print out 0. And then you want to find Q at 0, meaning you want to assign this value into the first item in Q, which was already initialized to 0. So initial flow rate times exponent of minus di times time. So this is the equation for the exponential model, and that time is 0. So anything raised over 0 is what? Is 1. So this is 1, and the flow rate at time 0 will be equal to QI, which is what I had told you to use for double checking your work. So that's fine. Then what does it do next? It grabs the next item in tvec, which is 1, and then it prints 1. And Q at 1 now will be this equation evaluated at 1. Are you done with all the items in tvec? No, we've just grabbed 0 and 1. So we move on to grab 2. So T will now be equal to 2. You print it out, it prints 2. Q at 2 is all of this, and now T is 2. And then you keep going until you get to 10. When you get to the 10th item, so T will be 10, print 10. Q at 10 will be this di times 10. And then it stops there because there is no 11. And it figures out you're done with the for loop because you have exhausted this collection. Now, this can be an array. It can be a list. It can be a tuple. It can be any data structure that contains multiple items. And this is any value you call it. You can make it T, you can make it W, you can make it anything. It's just going to keep grabbing the items in this data structure one at a time until you exhaust the list. Here you want to do the calculations on T, so we make T in TVEC and we get the results shown. So I run it. It doesn't run. Why? Because DI is not defined. I defined it earlier, but just to make this work, we can define it here. It's D underscore I. Python is case sensitive. And that's your T. First time is 0, second time is 1, 2, 3, and so on. Because you're still sitting in this loop, so it prints out this line all the way to 10. Then when you get here, you're outside of the for loop, and then you print all of the queues one time. And that's your queue starting out at 4,000 and it's reducing. Again, this is the kind of check you want to make so you can know whether you've made a mistake and fix it instead of turning in the wrong answer and losing points. Good. Counter. There is also the while loop, but the for loop is more commonly used, and everything you can achieve with a while loop, you can achieve with a for loop. So this is how the while loop works. You initialize a counter, and then while the counter is less than a value, say 4, you perform what's in the loop. So you print the counter. First time through is going to be what? 0. And then you increment the counter. So counter equals counter plus 1. What's the faster way to do this? All right, counter plus equal 1. Does everyone get that? And explain this plus equal sign before. So same deal. So now counter is 1. And then is 1 less than 4? Because counter is 1. Yes. So it goes into the loop and prints 1. And now counter becomes 2. Is 2 less than 4? Yes. Prints 2. Counter is 3. Is 3 less than 4? Yes. Prints 3. Counter is 4. Is 4 less than 4? No. Then it doesn't go into the loop anymore. Again, remember the two important points you have to remember with while loops, with for loops. The colon after the condition here and the indentation. You achieve the indentation with tab. Hit the tab on the keyboard, and then after the condition in the while loop, you put colon. Same here. The for statement for I in your collection, and then what? Colon. If you forget this colon, your code doesn't work and you keep trying to find what the error is. So remember, always double check for two things with your loops. The colon ending that line and the indentation right below that line. So anything you want to be nested within the loop has to be indented within the for statement.